Hi everyone, today I would like to talk about managing dot files. So we're going to learn what are dot files, why do you want to manage them, and what are the ways of managing them. If you're new to the channel, welcome. I typically create content around command line tools, Vim, and so on. If you are a subscriber, thank you for supporting the channel. Let's get started. So first of all, what are dot files? Dot files really are your configuration files. The name .file comes from the fact that most of the configuration files are hidden. This is signified in various Linux systems and Unix systems with the presence of dot before the file name. So .bashrc, .zhrc, .tmax.conf, and so on. So since the name. But dot files are really all the configuration files. They don't have to start with a dot, just a name. So why do you want to maintain, manage them, or version control? Most of the time, when you have a terminal heavy workflow, like myself, watching this video, you probably do, and you will definitely experiment with your files, add new functions, new scripts, change configuration of various programs, and you really want to capture this in a version control system, which is nowadays Git. There are, of course, other version control systems, but for the intents and purposes, Git is the one that you probably are using. You would like to use a service like GitHub or GitLab to actually backup your .files somewhere if your computer dies. So we have understanding of what configuration files are. Why do we need to manage them? So how? So there are three levels of managing .files. The most popular way of doing it is using something called a symlink. I'll learn what symlink is in a second. And you can essentially have .files repository pointing to a symlink in your home directory. You can do this manually by using an ln command. You can use various tools. One tool that we will look at is GNU Stow, and there are other community-driven tools that you can use as well. Manage everything, up to using full-blown systems like Nix Package Manager or Nix OS itself. There are various ways. So we will go from a very simple setup through middle setup up to using a tool. So first, let's look at how .files repository could. So here you can see a listing of my .files repository. As you can see, there are various files starting with a dot, which means those are hidden files, Linux parlance, but there are also regular files and folders as well. So this is my repository. The link to this repository is, as always, in the video description. And you can see that this repository has all the files. We'll see later a little bit more about it. So that's how a .files repository could look like. There are various ways of doing it. You can separate, let's say, a new Vim configuration in a separate repository. You can have less files, more files. It's all up to you. I use quite a few programs so that I have various .files that I keep track of. So before we start looking at .files, let's learn what is a symlink. So if you open the man page for symlink, it tells us that symlink is a symbolic link. It's literally like a pointer to other file. So you can think about it as something that isn't a file itself, but is a reference to existing file. Here we have a little bit more explanation. If you're using Linux, by the way, this video is applicable for Linux systems, all the all the various Nix systems, including WSL system for Windows, but this probably does not apply to those. I wouldn't know. I don't use Windows, but if you're using Mac or Linux, that's definitely be helpful. So you can, of course, read more about symlink, but it's enough to understand that symlink is literally a pointer to an existing file, and we use this concept managing our .files. So our actual files are in the Git repository somewhere on the folder, and the symlinks or pointers to those files are in our home directory where programs expect those files to be. So that's what Symlink is. This builds a base of the Dotfiles management. So let's look at a first tool that I want to talk through. It's called Stow. So Stow is really was created as a Symlink farm manager, and the original idea behind Stow predates programs like apt on Ubuntu or Yam or other package managers. And the idea was that you might have multiple administrators working together on one Linux system, and those administrators want to install programs. Those programs might have various files that they want to install, like man pages and config files and so on. And Stow essentially takes, at one hand, the source directory with various files, and you can point it to a directory. Let's say this example, this uses Perl, an example, but it could be anything. And you can then point it to a target directory. It will essentially create the symlinks. Stow has a very nice kind of heuristics of how it figures out what to symlink, what not to symlink, and so on. So instead of manually using the ln tag s command to create a manual symlink, you can use Stow to do it. And we'll see how it works. So let's see what options Stow has. So here you can see various options. So for instance, T for target directory, verbosity, Stow by default. Stow command means create symlinks. You can delete that the symlinks will be deleted, or you can restow. This means that you can both delete and stow together in one command. You can also use something called adopt, and this flag is interesting. If you have an existing file, the target directory, this file is not a symlink, or directory that is not a symlink, and you have the same file in your stow directory. So think about it with zshrc already present in your home directory, and you have zshrc in your .files. If you do adopt, Stow would essentially copy the zshrc from home directory to your .files, and then would create a symlink, which is actually what we want most of the cases. Obviously, at this point, we would to review it in our Git repository and actually discard the changes if we want to apply from our repository. But those are the flags of the Stow. It has some other interesting flags, but a command in and of itself is very simple to use. And a program that I chose to show you, kind of moving up progressively in the complexity of various tools to help us manage .files, called Yadm, yet another .files manager. One more that I'm not showing, but I want to tell you that it exists, is called Chez moi, if it's from French, or Chez moi. And this is a little bit more advanced .file manager. All those programs essentially encapsulate the same principle and make it easier to manage your .files. But the idea remains the same. Symlinks, you can use those programs to make it a little bit easier. So a bit about Yadm. You can see here, same concept. You can initialize so-called bare.files Git repository. Then you can use Yadm almost like overlay over your Git command. So you can do git add, Yadm commit, and so on. And it would add files to your repository, then symlink them back. All right, so let's see those things in action. So first of all, we're going to switch to a demo folder. So this is my .files repository. Let's create a folder. We're going to do folder one level up that we call test. And first of all, let's actually symlink something in this folder. So I'm going to open another pane, and then I'm going to do cd into test. So this folder is now empty, and I'm going to do ln s, and let's say we are going to do something like .files, this .files, and maybe z shell rc, and we're gonna symlink it to here. As you can see, now we have a symlink between a z shell rc file, which is actual file, and it is inside of my .files repository, and we symlink it inside of this dev.test. So if you run ls command, by the way, my ls command is alias to exa, so you would have to do regular ls command would be like this, ls.lh, and you can see the type that tells you that this shell rc file actually points to one level directory up .files shell. Okay, great. So that's how we did it manually using just ln.s command, creating a symlink. So what's going to happen if we delete this? So let's remove the visual RC file. So you can see it's no longer here. But when we go back to our repository, RC, you can see that the file is still here. It's important when you remove a symlink, you only remove a symlink. You remove a pointer to the file. You do not remove the actual file. So it's safe to remove the symlinks because the source files always remain. Okay, so let's see if we can actually use stow to symlink everything. So before we do this, let me show you one file. So I have this ignore, stow local ignore. This essentially tells stow which files and folders locally to ignore when performing stow. So just keep this in mind. Things like readme, license, shortcuts MD, and so on. They are going to be ignored when we run the stow command. So the stow command in its simplest form, just use stow, uses a current directory as a root directory, and it symlinks exactly in the same way how the directory is done. So if we do 3, maybe do like something like level 1, you see that this is the tree of my directory, and I want to show also hidden files. So here, this is what's going to be stored, excluding the files that we added to the ignore list. So again, here, so current directory by default, I want to do target test, which is a folder that we currently created, and then dot for showing everything. And if you see at our local, here our test directory, everything got symlinked. So all the files that we had, excluding the things we added to ignore list, are symlinked into our folder. Again, same principle applies, but instead of doing it manually, doing ln duck s command to everywhere, I use stow to do this. So if I want to unlink everything, I can just do -d, which is delete command, and you can see the test folder is empty. So that's how stow works. So let's do Yadm now to show you how Yadm works. So let's close this and clear it. And here I can do Yadm, and it tells me Yadm init. When I initialize, it tells me I initialize an empty Git repository under this path. So if we open second pane here and do this, you can see this is an empty repository. It doesn't have anything. We will actually see this later. And now it doesn't have Git, remote. It doesn't have any remotes. I'm not sure why our ls here. So here is the regular Git repository. We are inside the Git folder. Okay. Here, repo. So now we can swap to our home folder. By the way, cd by default swaps to home folder. And then we can say, okay, I want to add a file to my Yadm Git repository. So what I can do is I can do Yadm add, and let's say this log me log. When I do this, you can see that again, I don't know why this doesn't work, but let's say Yadm list. You can see the logme log has been added to this repository, and this is how Yadm works behind the scenes. So I can move this dead link to a command history. I'm not sure why this was there. Command history, and my files are managed exactly that by Stow. So to manage my own .files, I'm not using Yadm, I'm using Stow. Let me show you my setup again. So going back to .files directory, I have this just file. Just file is like makefile, but specifically designed to run commands rather than build anything. And you can see that I have this stow command. Same as you've seen earlier, I just use R for restow, and the target is my home directory. Excuse me. So now, let's say I'm going to run this. So just stow, and it tells me everything has been restored. There's no errors. We go through this output, but it's like a normal output saying that stow deleted all the links and reapplied them. But since we haven't added anything new to our repository, we didn't need to do anything. So let's close this part. And here we're gonna go back to home directory. And let's say that I want to add this logme log. So similarly, like we've seen with Yadm, but I have my own script. So this script, I alias to DAT, and the script, actually show this to you, files add, very simple script. It essentially takes parameter, and this parameter can be either a file or a folder, and it essentially copies this file or a folder to my .files repository, uses stow everything. So let's see how it works. So again, I want to add this logme log. So I so that logme log, and it says edit. So now if we do ls again, you can see that logme log is symlinked from my .files repository, and then you can see that I have this logme log here as this. The logme log has been added. I of course don't want it, so this thing to do, I'm discarding it, and I can remove logme log link, and I don't need this file. All right, perfect. So this was how you could manage your .files using Stow and using Yadm. Again, there are things like Chesmois and others that can help you. I found it easy to use my own setup using Stow, and very easy to stow, very easy to restow, and I can do this on any computer or on a virtual machine quickly. So a few tips and best practices. Remember that your .files backup is not a data backup. So your .files are really more about your configuration. So things like zshlrc, tmax.conf, neovim configuration, everything that is a configuration, you want to manage in this way. You want to back up your data. For example, you might want to back up your music, your documents, some form of data. This is a different process. I'll probably create a video around it. But one way to do this would be to use crontab. And you can see here I have two crontabs. That one that is done on reboot, and another that is done every hour, I believe. And this runs a backup script. So backup script, very simple, uses rsync, backup my data. Again, it's completely different than backing up your .files. I'm just showing it to you so that you know that the data backup process different from backing up your .files. So in my case, I'm using rsync and backing it up on my NAS, but this can go anywhere. You have to be careful with symlinks in a sense that you can delete symlinks safely. They are not going to remove the actual files, but you have to be careful the other way around. Sometimes it might be confusing what is symlinked where, and there might be various conflicts and so on. So there is a little bit of learning curve there, especially around Stow as a tool. But symlinks has their own quirks. And start, not start small. I suggest if you have maybe your zshell RC or bash RC and tmax.conf, or alacrity.toml or whatever programs that you're using, start super small. Literally one file is enough. Create a .files repository on GitHub or GitLab and follow, either manual linking with using ln tag s command or use stow. I suggest using stow because you can very easily add the .files there, and you will be having your .files safe and secure, backed up in case your machine dies, which inevitably happens at some point. Your disk can get corrupted, something happens, and it's very important to have this data backed up, your config files back. A few resources, actually one resource that has a lot of other resources. If you want inspiration, looking at other people's .files, how they solved the same problem, you can check this link, awesome .files list. GitHub, it has a lot of various .files. Yeah, otherwise, that's all for today. Thank you for tuning in. I hope you learned something, and I hope you will create your .files repository today. If you haven't done so, you'll thank me later. This is very important to back up your It's important to back up your configuration. Then keep adding. Remember, start small, start simple. Don't overcomplicate it. Just make a repository and start symlinking files, and you'll not lose your data. All right. Thanks, and as always, see you in the next video.